Alright, so this morning we're going to look at atomic structure. We're going to look at what atoms are made of. Atoms contain three subatomic particles, protons, electrons, and neutrons. Protons are going to be positively charged, and they are equal to the atomic number. So, for example, nitrogen, which has an atomic number of 7, has 7 protons. The electrons are negative. If it is an atom, meaning it's a neutral particle, meaning it doesn't have a charge, then the number of electrons is the same as the number of protons. So for nitrogen, um, a, a neutral atom of nitrogen would have 7 protons and 7 electrons. I'm getting that off the periodic table. If it's an ion, so ion being a charged particle, then the number of electrons can change. If it's a cation, meaning it's positively charged, then it's lost electrons. So for example, magnesium atomic number 12, a neutral magnesium is going to have 12 electrons. Magnesium plus 2, well, I lost 2 of those negative charges, so I'm going to be down to 10 electrons. Okay, so you're doing the opposite of the charge. If it's a positively charged, then I lost electrons. If it's a negatively charged, then I gained electrons. So for example, oxygen. Oxygen has an atomic number of 8. So in an electrically neutral atom of oxygen, I'll have 8 electrons. In O negative 2, I will have gained 2 negatives. So 8 plus 2 is 10. Okay. So you just have to check the ion to determine what's going on with the electrons. And then the neutrons is going to be the mass number minus the atomic number. So if we go back to our example for nitrogen, nitrogen with an atomic number of 7 and a mass number of 14 would have 7 protons, 7 electrons, 14 minus 7, 7 neutrons. Now we have these things called isotopes. Isotopes are atoms that have the same number of protons and different number of neutrons, and this different number of neutrons will affect the mass. So it's not going to affect the charge. The charge is only affected if I manipulate the number of electrons. What this is going to change is the mass number of the element. So we have two ways we write it. The first is with the mass number and the atomic number. So mass number goes on top. That's why you see a 15 here. This is an isotope of nitrogen. The atomic number goes on bottom, 7, and then the charge goes in the upper right-hand corner. So what this is telling me is this atom of nitrogen has 7 electrons. It has 7. It's lost 3. So 7 minus 3 is 4. It has 4 electrons. And then the atomic, the mass number is 15. 15 minus 7 gives me 8 neutrons. The second type of isotope designation, the way we know it's an isotope, is by writing the element symbol and then the mass number. So uranium-238, if I was going to do this for carbon, it would say C12 or C13 or C14 because those are all naturally occurring isotopes of carbon. And what differs in an isotope is the number of neutrons. Number of protons will never change. Number of protons is the identifying piece of information for any given element. Number of electrons can change. If I lose electrons, I become positively charged. If I gain electrons, I become negatively charged. Number of neutrons changes, and that affects my mass number. So let's just do a couple of practice problems to make sure that you understand the concept. So we'll start with the first one, hydrogen. Hydrogen's atomic number is 1. Its atomic mass is 1. Let's combine atomic mass and mass number into one column. So I'm going to put atomic mass or mass number in this column, and I'm not going to worry about this middle piece. So the number of protons is equal to the number of the atomic number, so that's 1. The number of electrons in an electrically neutral atom, there's no charge on this hydrogen, is equal to the number of protons, so that's 1. The number of neutrons is equivalent to the mass number minus the atomic number. So 1 minus 1 is 0. H plus has a plus 1 charge. So its atomic number is still 1, its mass number is still 1. The only thing that's going to change is the number of electrons. The number of protons is equal to the atomic number, 1. The number of electrons, well, I have a +1 charge, which means I lost 1 electron, meaning that if I lose the 1 electron I have represented, I go to 0. Again, atomic mass minus atomic number gives me neutrons. 1 minus 1 is 0. H-2. That's hydrogen with a mass number of 2. Atomic number doesn't change, it's still 1. Mass number is 2. It's not a charged particle, so it has 1 proton, 1 electron. Mass number minus atomic number, 2 minus 1, gives me 1 neutron. The next example is oxygen. Oxygen with a mass number of 16, atomic number of 8, and a charge of -2. So the atomic number is 8, the mass number is 16. Number of protons is equal to atomic number, 8. Neutrons is equal to the atomic mass minus the atomic number, 16 minus 8 is 8. And the number of electrons. Well, I started with 8 and I have a -2 charge, which means that I gained 2 electrons. 8 plus 2 is 10. The next example I have is sodium. Sodium with a mass number of 24 and an atomic number of 11. There is no charge on this sodium, so both my protons and electrons are equal to my atomic number. Neutrons are going to be equal to my mass number, 24 minus 11, 13. The next one, uranium-238. 238 is my mass number. To find the atomic number, I'm going to have to use my periodic table. Uranium is atomic number 92. So it's a electrically neutral atom. There's no charge. So protons and electrons are both equal to atomic number, 92. Neutrons will be equal to mass number minus atomic number. 238 minus 92 gives me a number of neutrons equal to 146. Chlorine, 37. 37 is the mass number. I go to my periodic table to get the atomic number for chlorine, 17. While you're there, note the atomic mass of chlorine. This is an isotope of chlorine, meaning it's going to have an abnormal number of electrons. It is neutral, so both protons and electrons will be equal to the atomic number. Neutrons will be equal to 37 minus 17, 20. Alright, just magnesium. So for this one, I'm going to have to get all my information off the periodic table. Atomic number of magnesium is 12. Atomic mass is 24. It's not charged, so both the protons and electrons are equal to 12. Neutrons will be equal to 24 minus 12, 12. Alright, I'm going to work one more, and that's calcium 2+. So calcium 2+, again, I'm going to have to get all my information off the periodic table. Atomic number is 20, atomic mass is 40. I have 20 protons. I have a +2 charge, which means I lost 2 electrons. 20 minus 2 is 18. And then to obtain the number of neutrons, I take the mass number minus the atomic number, 40 minus 20, to get 20. Atomic structure is very easy. You just have to be familiar with the isotope designations and be familiar and know how to read your periodic table.